My name is David Saxteen, MCT and MCPD in Enterprise Application Development, John Bryce Training. Today, I'm going to give a short discussion on addressing the challenge of change in software using design patterns. Today, we will begin with a description of the challenge of change. We will understand what it is about software that requires us to address this challenge. Then we will take a look at some of the design principles that help us address the challenge. Followed, we will discuss design patterns as a tool for using and implementing these principles. And then we will summarize. In order to understand the challenge of change, let's begin with a review of some of the software development goals that we always need to address. We need to meet specific requirements, and we need to meet specific constraints. The constraints are often time, budget, and of course other resources. But in addition to all of these functional requirements, we must also have the ability to test our software efficiently, maintain the software in the future, and extend it when necessary. Interestingly enough, there is only one real constant in software development, and that is change itself. It turns out that most of the resources that we invest in a software project are actually incurred after the release of the project, and that is due to the various changes that the product needs to undergo. There are many reasons for change. To mention just a few of these, there may be errors in the original requirements. It's not always a problem of the programmer. Often there are incorrect requirements or a misunderstanding with the customer when the requirements were analyzed. And of course, there are also errors in implementation, what we call bugs. Furthermore, software may be required to change because there are new requirements. And then, of course, there are many other reasons that the programmers themselves would like to do redesigns in order to make all of the other changes more efficient and easy to do. So there are many reasons for change, and in fact we must always take into account that software will change over time. In order to make that possible, let's review some of the very basic good design principles, and these are just a few. But these are very important ones that will help us keep on the track of enabling change that will inevitably come. So first of all, we'll talk about loose coupling. Then we'll talk about the principle of least knowledge. We'll discuss how to make our components more simple. We'll talk about extensibility. And finally, as an example of extensibility, the inversion of control. Having discussed design principles, we'll take a look at the motivation for design patterns. Let's begin with loose coupling. Loose coupling means to remove the dependencies between components. This enables us to modify and to change each component separately and reduce risk and effort in those changes. So first of all, what do we need to do? We should separate components that change at different rates. This means that one change will not affect the other component. Second, we should program to an interface and not to an implementation, or if you like, to an abstraction rather to a concrete implementation. A third principle, which is often debated, is favoring composition over inheritance. Inheritance in most languages introduces compile time coupling, and if that can be avoided and where necessary, we should use composition. And of course, we should try to prevent cyclic dependencies, which of course make it much more difficult to isolate change to one particular component. Unlike in the real world, knowledge is not power in software. In fact, knowledge creates dependencies. Dependencies expose information. Dependencies actually prevent us from making changes easily to one component that do not propagate to changes in another component. So if knowledge creates dependencies, we should try to implement our modules with as little knowledge from the outside world and from other components as possible. We expose information on a need-to-know basis. Only what you need to know to implement should in fact be exposed. And as a good example of this, there is the interface segregation principle. Even when you program to interfaces, those interfaces should not be monolithic descriptions of all of the aspects that a component can implement. Rather, there should be a segregation, a separation of different aspects of that object's capabilities, each in its own interface. And then, of course, there is simplicity, a very important design principle in itself. There are many ideas here that can be associated with simplicity, but a few that I would like to discuss, which may be quite surprising: implement only what is required. We will see in the next slide that it does not mean that you cannot be extensible for the future, but I do emphasize that do not implement today what you do not need today. Another principle related to simplicity is that a class should only have one reason to change. This is the principle of single responsibility. This makes classes easier to understand and easier to maintain. And it also means that they are much easier to change without changing other features that weren't intended. And then, of course, we should try to find a balance between spaghetti code and macaroni code. And what do I mean by this? Spaghetti code is code that has many dependencies, and therefore components become very complex. Macaroni code is code that is made out of components that are so small, just like macaroni, that they barely do anything themselves, and they require a programmer review many different components just to understand what the module itself is doing. So classes need to have some sort of balance between being spaghetti and being macaroni.